how do you measure the mass of common objects? So if I talk about that, we have weighing scales. They can be digital, they can be mechanical, right? So mechanical ones you might see on a vendor, all right? So a street vendor who is measuring the weights of, let's say, apples or any other vegetable. But in this case, when you want to measure the mass of very, very tiny objects, which are atoms, you cannot use a weighing scale. The first thing is you cannot individualize each and every atom. You cannot separate them and keep them on a weighing scale. And apart from that, if you want to do that, let's say you have some technology, and actually we can separate those atoms. But the thing is, what is the physical thing on which you keep those atoms, and then you can actually measure the weight of that atom? Because 10 to the minus 27 kg, it's very, very less. So we have to develop an equipment which is sensitive enough so that it can detect the mass of the smallest particles of this universe. Now, what is that device and what is the technology behind that? And actually, we have that, and the technique used to detect the mass of the tiniest of tiniest particles in this universe, that technique is very brilliant. Okay, so let me tell you about that technique, and that technique is called as mass spectroscopy. Okay, once again, it's major details you will learn in higher classes, but here I'm just going to introduce you to the genius behind this. It's very brilliant. Now see, once again, we go with the magnetic field and electric fields in this case. See, we have learned that any charged particle, when it is moving through a magnetic field, it will experience some force. Okay. Now from Newton's law of motion as well, we know that force is equal to mass times acceleration. That's one thing. Another thing is, if something is having some force and you need to change its direction, the object is going to resist that. We know that this is basically the inertia. And remember, we know that inertia is related to mass, right? Mass is basically the measure of inertia. So that means higher the mass, higher is going to be the inertia. So that means if something heavy is going like this and you want to change its momentum, in that case you have to apply a higher amount of force. Let's say you apply less amount of force, in that case its momentum is going to change less. So if the momentum changes less, in that case I can say that the object has high mass because it had higher inertia. It did not change its motion very easily. If that object changes its motion or its direction very easily and drastically, in that case I can say its mass is very, very less because its inertia is less. By applying a very tiny amount of force, you have changed its direction drastically. Okay, and that's what we are doing here. What we basically do in a mass spectroscopy is, I have a sample, so I have a bunch of atoms which I want to measure its mass. Okay, so the sample is sent here, but the thing is that sample needs to be charged, because we know that only charged particles experiences a force in a magnetic field, uncharged particles do not. In this case, what we are going to do is, we have some sample. What we do is, there is this electron beam. This is to ionize those atoms so that some electrons are knocked off, so that it has some charge. Now these charged particles, they are sent through these magnetic field like this. Okay, so there's huge magnet like this, and the charged particles enter into the magnetic field, and here there is a detector. So more is the deflection of atoms, less is the mass. Deflection is related to the mass of those atoms. So basically here there are other devices which detect these atoms which are bombarded on this detector, and based on the amount of deflection we can calculate the mass. This is the brilliance behind this. So this is just an overview. The mathematical part, the more detailing, you are going to learn in your much higher classes, probably after 12th. Okay, but in this case here, this is the genius behind this. This is how we can calculate the mass of the tiniest of tiny particles of the universe. Okay, so here just to give you an overview of what are the range of masses that we come across in this universe. Okay, so here we can see that the mass of an electron is approximately 10 raised to the power minus 30 kg, very small. And then the mass of the known universe is about 10 raised to the power 55 kg. Once again, this is a number, it's so huge that it's physically very difficult to even comprehend how large this number is. It's very huge. Okay, so 10 to the 55 kg to 10 raised to the power minus 30 kg. These are the range of masses that we usually come across in this universe. Okay, thank you.